So I have sent you in the group. Just now look in the group. Okay. Right. So we were studying about moment of force. So last class we understood what is a sign convention we use for moment. Okay. So you can take any sign convention, but we prefer anti-clockwise positive and clockwise negative. Okay. Then we started looking into forces. Inclined ആയിട്ടുള്ള ഫോഴ്സുകൾ വന്നു കഴിഞ്ഞാൽ മൂവ്മെന്റ് എങ്ങനെയാണുള്ളത് നമ്മൾ പിന്നെ കണ്ടുപിടിക്കും. Okay. So this also I gave you 4 questions as assignment. Most of you have done that. There are few people who have not done that. So make sure that you are doing it. Your assignments late cheyyanam. Okay. Right. So one thing that I want to tell you about this is there is a name to this. So this I want to just tell you. This method means taking components. Okay, when you're taking components and finding the moment, this is known as Verignon's. Verignon's Verignon's method of theorem. Okay. Verignon's method in the theorem. Answer theorem now in the Verignon's theorem and Verignon says that the moment due to a force is same as the moment due to the components of the force. Okay, that's Verignon's theorem. So I did not mention this because sometimes in the exam Verignon's theorem which is the moment Verignon's theorem so don't do that. Okay. So just we have studied that. Only thing is I just want you to know that this is that. Okay. So we have identified problems. Okay. Now what we have to do is I want to introduce you to a new concept. Okay. So we know what is equilibrium. Equilibrium already what is equilibrium. But what we have studied now in equilibrium is if you have a point and there are some forces in this, if the resultant force is 0, then it is in equilibrium. Then it is in equilibrium. Okay. So this is basically translational equilibrium. Okay, translational equilibrium. Translation, what is translation? So there is a ball here. It has moved to this point. This is translation. Or this has moved to this end. That is translation. Okay. Now, what is the other equilibrium that we also want to know what is known as rotational equilibrium. Rotational equilibrium. Rotational equilibrium. Now, rotational equilibrium means what? The body should not rotate. We are studying everything in rigid body. Okay, rigid body. Rigid body is bendy at the body. Okay, so for example, if you can see, my scale is there. Scale, if I am pushing forces like this, it is bending. So this is not a rigid body. Okay, it is not a rigid body. But if I take, let's say, something bigger. So let's say my speaker is just still. So if I apply force, it is not rotating. It is not bending at all. So that we can assume to be a rigid body. So we know what is how do you find translational equilibrium. Translational equilibrium is direction move. Okay, rotate move. The condition to satisfy is the resultant of the forces should be 0. Now what is the condition for rotational equilibrium? One body rotate condition. Okay. Now so the point that I want to make is like this. So let us go back to our yesterday's class, last class. Let's say I have a road here. a thick rod or a rigid rod is there. Okay, so whatever normally e class okay, it's about rigid body. Okay, so whatever when I am drawing something, you have to assume it to be rigid. So I have already told you എന്താണ് വ്യത്യാസം നമ്മൾ rigid flexible അല്ലെങ്കിൽ deformable. Rigid ന്റെ opposite is deformable bodies. Rigid അല്ലാത്ത bodies is deformable bodies. അപ്പോൾ ആ സ്കെയിൽ ആണ് deformable body എന്ന് ഞാൻ പറഞ്ഞത്. ആ ഒരു ഇതാണ്. അപ്പോൾ ബേസിക്കലി again ഇതൊക്കെ ഞാൻ നേരത്തെ ക്ലാസ് പറഞ്ഞ നമ്മൾ ഡിപെൻഡ്സ് upon the force. നമുക്ക് ഈ ഒരു ബോക്സ് ഞാൻ റിജിഡ് അല്ലെന്ന് പറഞ്ഞു. അപ്പോൾ ഇഫ് യു അപ്ലൈ എ ലോട്ട് ഓഫ് ഫോഴ്സ്, ഒരുപാട് ഫോഴ്സ് ഇത് അപ്ലൈ ചെയ്ത് കഴിഞ്ഞാൽ അത് ഇത് ചിലപ്പോൾ ഡിഫോമബിൾ ബോഡിയായി മാറും. സോ ഡോണ്ട് ഗെറ്റ് കൺഫ്യൂസ്ഡ് വിത്ത് ഓൾ ദോസ് തിങ്സ്. വാട്ട് എവർ വി ആർ ഡീലിംഗ് വിത്ത് ദിസ്, നമ്മൾ അപ്ലൈ ചെയ്യുന്ന ഫോഴ്സിൽ ഇതിൽ ഡിഫോർമേഷൻ സംഭവിക്കും. അതായത് ഇതിന് വളവോ തിരിവോ അങ്ങനെ ഒന്നും സംഭവിക്കുന്നില്ല. only thing it can do is it can move like this, it can rotate like this, ഇങ്ങനെ റൊട്ടേറ്റ് ചെയ്യാം. ഇത് രണ്ടുമേ ഈ ബോഡിക്ക് ചെയ്യാൻ പറ്റും. Okay, so that you have to know. That is within which we are trying things. So let's say this is a body, a body. Now let's say what is, I have a force here. I'll call this force, let's say 10 km. Okay, I have another force here, let's say 20 km. Let's say I have another force here, let's say 30 km. Okay, so these forces are what is known as parallel forces. They are not concurrent forces. They are not concurrent forces. So these forces are not concurrent. So this is not concurrent force. This is not concurrent force. This is not concurrent force, because they are not applying on a point. It is, they are not coming to a point. They are coming at and applying at different points on the object. The object in we cannot assume in the object. We cannot assume it to be all the points. Okay, so these forces are known as these are basically parallel forces, parallel forces. Okay, now parallel force in the sense, how can we define this equilibrium? Okay, if we concurrent force in the equilibrium, some forces, some forces, the resultant is 0, we can say it is an equilibrium. Okay, equilibrium is translational equilibrium. Okay, now what about this? How do you say about this? Okay, so it is again simple. What you have to do is you have to find the sum of the component of forces in x direction. Okay, now again resultant equal to 0 in the same then x component of all the forces are 0, y component of all the forces is 0. Find the sum of the components of forces in x direction and y direction. Okay, now if both sum are same, both summation, so this I'll call as summation of fx, this I'll call summation of fy. If both summation of fx and summation of fy equal to 0, then the body is in translational equilibrium. Is in translational equilibrium. Okay, translational equilibrium. So now let us we will come to rotational equilibrium. But you have to understand this in the translational equilibrium. Okay, so here we are not talking about forces which are acting in one point. We are finding forces which are acting at different locations. Okay, but they are parallel. They are parallel. You can see this force will occur parallel. Now let us see whether it is in translational equilibrium. Okay, now let us take this question. We will take it to the next slide. Then one by one we will start studying. Okay. Let's say create a slide here. Just rub this off. Right. Now, what is the forces in summation of forces in x direction? Summation of forces in x direction. Okay, so this is basically what is the component of this force, green force in x direction? It is either the vertical, so it is 0. Okay, what is the component of this red force? It is 0. What is the component of this red force? It is 0. So x directional force 0. It is it is 0. Now, what about y? What is the all the forces in y direction? So let's say I assume up as positive. But here I am assuming right as positive. Okay. Up മേലോട്ടുള്ള ഫോഴ്സുകളൊക്കെ പോസിറ്റീവ്, താഴോട്ടുള്ള ഫോഴ്സുകളൊക്കെ നെഗറ്റീവ് ആണ്. Right? So what about this? This is താഴോട്ട് minus. It is minus 30. Okay. Now this is plus 20. Now this is plus 10. Okay. Now this gives me 0. So this means this rod is in translational equilibrium. It is in translational equilibrium. Translational equilibrium. Okay. So that means this rod, it will not move like this. Even though our other direction of force applied on it will not move like this. Okay, it will still in this direction. Translation wise, it will stay. Now let us say I will find moment of this force. Let's say in the distance I will give you. Okay, this is 1 meter. This is 1 meter. This is 1 meter. Okay, let's say this point is A. Right? So you tell me what is the moment. Find moment about A. So I'll give you 2 minutes. Moment tell me what is the moment about A. Okay. So I'll call some names. Then you solve it. Okay. Okay. Answer also you can if you got the answer, you can raise your hand. Find the moment about. നിങ്ങൾക്ക് കാണുന്നില്ല, ഞാൻ എഴുതുന്നത് നിങ്ങൾക്ക് കാണുന്നില്ല, ഞാൻ ബോർഡ് കാണുന്നുണ്ടല്ലോ അല്ലേ?
ഉണ്ട് സർ.
Okay. Please calculate what is the moment of this point of all the forces about A. Okay.
സാർ 40 ആണ് സാർ. ഡയറക്ഷൻ പ്ലസ് മണ്ടക്കോട്ട് ആന്റി ക്ലോക്ക് വൈസ് ഡയറക്ഷൻ.
So Altaf is telling me this plus, huh? Altaf
ആണ് സാർ.
Anti clockwise, huh?
ആന്റി ക്ലോക്ക് വൈസ്.
Okay. Any other answers or anyone else got this answer?
Yes, sir. 40 minutes.
Sir, 40.
Shahid also is telling me. Arjun Ajima also is telling me. Ale?
Yes, yes.
Okay, let's see. So you know how to do this. So what we do, we assume anti-clockwise is positive. Anti-clockwise is positive. Then what? Wait, 30 die. Then 30. So 30 is trying to rotate in clockwise direction. So 30 times 1 with a minus sign. Okay, so that is for 30. Now 20 is trying to rotate in anti-clockwise direction, so that will be plus. (20) times what is the distance? 2 meters. Okay. Now what about 10? 10 also is trying to rotate in anti-clockwise direction. So 10 into 3. 1, 2, 3. Okay. So this is minus 30 plus 40 plus 30. Okay, so that means plus 40. So plus indicate it is anti-clockwise direction. So it's absolutely correct. Right. Now, so if the summation of movement or movement about this point is not 0, then it is not in rotational equilibrium. Not in rotational equilibrium. That this is not in rotational equilibrium. Right. So so this is how we know whether a body is in rotational equilibrium or not. Okay. If the sum of the moment of the body is equal to 0, then it will be in rotational equilibrium. If it is not, it will not be in rotational equilibrium. Okay. So, right. Now, you can ask me, sir, just give me a moment. Yeah. So, which point should I take? Should I have to take with about A? The point about check vertical direction and all, you don't have to worry about it. Equilibrium, translational equilibrium, total forces in x direction, total force in y direction. Point into you just have to take the force. Now, movement depends upon which point you are taking. Okay. Now, the idea is if a body is in rotational equilibrium, rotational equilibrium, this body is not in rotational equilibrium. Ultimately, what is happening is it is going to rotate something like this. It's going to rotate. Okay, it's going to rotate the body. That's rotational equilibrium. So, this is move, but about some point it will keep on rotating. Okay, so we can even find that point also. So that will come in later. But it will keep on rotating like this. That is going to happen for this. So it is not in rotational equilibrium, but it will not move like this. It will not move like this. Now, about what point? Any point. Let's say you want to take movement about this point. Okay. Then also, if it is in rotational equilibrium, rotational. So I think I will take another problem. Then you will understand. Okay. So let's see. So let's say I have a force, let's say 100. Okay, then I have a, let's say, force here 50 km, and there's a force here 50 km. Okay, now you have to check. Let's say this is 1 meter. This is also 1 meter. Okay, now there is a point here. Let's say this point A. Now you have to tell me if the arrangement, check whether the system or this road, this is a road, okay? This is a road. Rigid road, okay? So you have to check for translational and rotational equilibrium of the rod. Okay, so you have to check whether the rod is in translational and rotational equilibrium. Okay, well, then we'll check it out. Let's see how do you check this. Check you check for translational equilibrium. Translational equilibrium, check, you just have to check some of the x direction force is equal to 0, some of the y direction force is equal to 0. So either under values we will you, then we will see rotational equilibrium. Okay, so on the try you just give, I'll give you 2 minutes to try. Translational equilibrium, anybody has checked?
Yes, sir. Yes, translation. Equilibrium. Yes, sir.
Okay. If you are done checking that, you have to find moment about A. Okay. So how do we do that? Let's say we will take summation of all the forces. Okay. So Fx is right hand horizontal directional force. So I'll take right force as positive. Okay. So what is a right force here? There is 0. X directional force illa. X directional force illa. There is no acceleration force. The total force in x direction is 0 because the force is bi-directional. So there is no force in x direction. Now, what about y direction? So y direction, let's say I'll take up as positive, upward as positive. Okay. So that means I have a 50 here. I have a minus this, and I have a plus 50 here. This also gives me 7. So this means it is in translational equilibrium. Translational equilibrium. Right? Now, I hope this is clear. Again, translational equilibrium. But the body translational equilibrium, you have to understand basically in the try body or a force acting under. A force is a body move. Okay. So that is what you have to see. Right. Now, try to find moment about A. Are you moment about A can do it?
0, sir.
Who is that? Ara?
0. Sir, 0.
Yes,
Sir, 0.
Aslam is there? Aslam?
0.
Aslam
0, sir.
Aslam is there? Aslam Muhammad? Aslam illa. Aslam Muhammad is there? Bibin is there? Bibin? Bibin undo? Bibin? Bibin is absent. Okay. Fine. Let's see. How do you find moment about A? moment about A. Okay. Now let's say because of this force is 50, but there is no perpendicular distance. So it is basically. So how do you say? So I'll assume clockwise as positive. Okay. Now 50 times 0. So because it is passing through A. Now let's say it is 100 moment, it is in clockwise direction, so it has to be minus 100 times 1. Now again for 50 it is an anti-clockwise. This will try to rotate in anti-clockwise direction. E point. So forget all of the points when you are considering this force. Force. So this force is trying to basically it is trying to rotate in this direction. So it is anti-clockwise. So it is also positive. Plus 50 times 2. Okay, so this is 0 minus 100 plus 100. So this means 0. Okay, so this, since summation of moment is 0, it is in rotational equilibrium. Rotational equilibrium. Why did I choose this point? Can I choose this point? Okay, now let's say we choose point B. Find moment about B. Moment about B. Find moment about B. So please find moment about B. Answer.
അതും 0 ആണ് സാർ.
Let's see. So let's say moment about B we are finding. We'll again assume clockwise as anti-clockwise as positive. Now this is a force. Okay. Now let's say this 50. E50, it is trying to rotate it in clockwise direction. Right? So I can write 50 times minus 2. This is trying to rotate in clockwise direction. This 100 is trying to rotate in anti-clockwise direction. So that is plus 100 times 1. Okay. Then this 50 is passing through B, so it will not have any impact. So this gives me minus 100 plus 100 equal to 0. Okay. So this is the meaning of rotational equilibrium. Now let's say, so it is not still over. Let us say I will take another point here, C. Let's say I will take another point here, C. Okay, it is in horizontal line. Let's say this is 1 meter. Okay, so tell me what is the moment of these forces about C? What is the moment of forces about C? Moment about C. What is the moment about C? So this is 1 meter. I mean, it is outside the body. Body is but still I am asking you what is the moment. You can tell. We plain about any point you can find out. Okay. So that is what I am trying to tell you. Now, what is the moment about point C? So I think I will pause. Anna Joseph undo.
Yes, sir.
Anna in the meeting Anna. Anna message കണ്ടിരുന്നോ?
അന്ന മരിയ വരുന്നു.
മരിയോ? അന്ന മരിയ അല്ല അന്ന ജോസഫ്.
സർ ഞാൻ വരാന്ന് പറഞ്ഞില്ലായിരുന്നു.
വരാന്ന് പറഞ്ഞില്ല, വരില്ലെന്ന് ഞാൻ ചോദിക്കുകയാണ്.
ഓക്കെ സർ.
ഓക്കെ, അന്ന പറഞ്ഞോ.
അതും സീറോ അല്ലേ?
അതും സീറോ ആണോ? ഓക്കെ. അന്ന കിട്ടിക്കോ, അന്ന കിട്ടിയ ആൻസർ. അന്ന ജോസഫിന് കിട്ടിയോ ആൻസർ?
സീറോ സർ.
ആണോ? അന്ന മരിയക്ക് കിട്ടിയോ? അന്ന മരിയ ഉണ്ടോ അവിടെ? അന്ന മരിയ ഉണ്ടോ? നിങ്ങൾക്ക് കേൾക്കാനും പറയാനും പ്രശ്നം ഉണ്ടെങ്കിൽ യു ഹാവ് ടു ടെൽ മീ. ഓക്കെ, നിങ്ങൾക്ക് എന്തെങ്കിലും മൈക്കിന്റെ ഇഷ്യൂസ് ഒക്കെ ഉണ്ടെങ്കിൽ യു ഹാവ് ടു ടെൽ മീ. അതൊക്കെ നമുക്ക് കറക്റ്റ് ചെയ്യണം. ഓക്കെ. അതീന, ഡിഡ് യു ഗെറ്റ്?
Yes, sir.
എന്താ കിട്ടിയ അതീന? എത്ര ആൻസർ കിട്ടിയ?
Zero, zero.
Zero കിട്ടി. ഓക്കെ. So let's say നമുക്ക് ചെയ്ത് നോക്കുന്നുണ്ട്. So let's say again clockwise we'll assume to be positive, anti-clockwise we'll assume to be positive. So 50 is at 1 meter. It is trying to rotate it in anti-clockwise direction. So that is positive. So 50 times 1. So it is a positive force. Now, what about this 100? 100 is trying to rotate in clockwise direction. So that has to be minus. So I'll write the sign now. 100 times, what is the distance? 1 plus 1, 2 meters. Okay. Now what about this? This is again trying to rotate. The movement is in anti-clockwise direction. So that is still positive. So 1, 2, 3, 3 meters. Okay. So this is what we'll say: plus 50 minus 200 plus 150. So 150 plus 50 is 200. 200 minus 200 is 0. Okay. So this is the meaning of rotational equilibrium. That is, if you have a plane, you have parallel or any forces, any set of forces acting. If you parallel, let's say forces like this, forces like this, forces like this, forces like this. Okay. But ultimately, about any point in this plane, you are finding the moments due to this force. If that is 0, then this body will not rotate. Okay, so a body rotating condition. So this is what is rotational equilibrium. I told you we have a translational equilibrium, we have a rotational equilibrium. Okay. So when there is a rotational equilibrium, this will not happen. The body will not rotate. It will rotate. About center some other point. Let's say some other point it can rotate like this also. Some point. Less of that we can find. We can even find about which point it is going to rotate. Okay. So basically, this is what you mean by rotational equilibrium. Okay. So that means it is not rotating. So this body will not rotate or it will not translate. Okay. This is a it is a very common structure. Bridges bridge. So let's say ചെറിയ പുഴകളുടെയൊക്കെ പുഴയല്ല തോടിന്റെ ഒക്കെ മേലെ കുറെ ബ്രിഡ്ജുകളുണ്ടല്ലോ. അപ്പൊ ബ്രിഡ്ജിന്റെ ഈ സൈഡിലുണ്ടാവും കല്ലൊക്കെ കെട്ടി. കല്ലൊക്കെ കെട്ടിയിരിക്കും. ഇതിൻ്റെ അകത്തൂടെ വെള്ളമുണ്ട്. ഓക്കെ. So this is this kind of structure, ഈ structure. Let's say you are standing here. Okay, this is idealized like this. ഇങ്ങനെ നിങ്ങൾ നടക്കുമ്പോൾ ബ്രിഡ്ജ് കറങ്ങുന്നുണ്ടോ? ബ്രിഡ്ജിൽ നിന്ന് കറങ്ങുന്നുണ്ടോ? ഇല്ല. ബ്രിഡ്ജിന് എന്തിനു സംഭവിക്കാം? ബ്രിഡ്ജ് അങ്ങോട്ടും ഇങ്ങോട്ടും മൂവ് ചെയ്യുന്നുണ്ടോ? ഇല്ല. ബ്രിഡ്ജ് താഴോട്ട് വരുന്നുണ്ടോ? ഇല്ല. കാരണം ഇറ്റ് ഈസ് ഇൻ ഇക്വിലിബ്രിയം. അത് ഇക്വിലിബ്രിയത്തിൽ ആയതുകൊണ്ടാണ് അത് അങ്ങോട്ടും ഇങ്ങോട്ടും നീങ്ങാത്തത്. ഓക്കെ. സോ ഇത് നിങ്ങൾക്ക് നിങ്ങളുടെ ഈ കോൺസെപ്റ്റ് നിങ്ങൾ ഇങ്ങനത്തെ വലിയ ബ്രിഡ്ജുകളിലോട്ടൊക്കെ നമ്മൾ എക്സ്റ്റെൻഡ് ആവുന്ന കോൺസെപ്റ്റ്. സോ ദിസ് കോൺസെപ്റ്റ് വെരി വെരി ക്രിട്ടിക്കൽ. അപ്പം സ്ലോലി നിങ്ങൾ ഇത് പയ്യെ പഠിച്ച് നിങ്ങൾ ഇങ്ങനത്തെ സ്ട്രക്ചറുകളിലോട്ടൊക്കെ കയറി തുടങ്ങും. Okay, അപ്പോൾ അതിന് മുന്നോടിയായിട്ട് you have to know that what is happening, why is happening. Okay, so that is about rotational equilibrium. Now what we have to do is we have to do a lot of problems. അതിന് മുമ്പ് there's another concept that I want to teach you. It's the concept of couple. Now this couple we will take in the next class because we will take that because I want to do some other kind of problem today. അപ്പോൾ ഇതുമായിട്ട് റിലേറ്റഡ് അല്ലാത്ത ഇപ്പൊ മൊമെന്റുമായിട്ട് റിലേറ്റഡ് അല്ലാത്ത or this 2 or 3 different kinds of problem I have to tell you, okay, because before exams. So let's say I'll take my compass, smallest size, draw 2 circles. Right. Okay. Now we have studied rotational equilibrium, we have studied translational equilibrium. Now let's, for a moment, we will forget about moments. We go back to our basic class. Let's say now this is a wedge. Let's say this angle is 30 degrees. Okay. Let's say the weight of 2 balls, weight of 2 identical balls or rollers. The weight of 2 identical rollers are 500 Newton each. Okay. The rollers are in equilibrium. KTU. Okay. Find the forces exerted by the walls on the rollers. Okay, this is the question. Okay, so okay, so this 500 Newton or roller weight. Okay, right. Now assume frictionless. Assume to be frictionless. So this is frictionless. Frictionless walls. Okay. Now, first thing is evidake walls iduvayitte contact. Okay. Now, where all we get the forces? So what you have to do is, I'll name this. This is A. This. Okay. First, you have to draw the free body diagram of these two. Free body diagram you raise your hands. Free body diagram. So, so you free body diagram. Body diagram പഴയ കോൺസെപ്റ്റ്സ് ഒക്കെ നിങ്ങൾ തിരിച്ചെടുക്കണം. സോ നിങ്ങൾ ക്ലാസ് കഴിഞ്ഞിട്ട് ഇഫ് യു ചെക്ക് യുവർ മെയിൽ, ഐ ഹാവ് സെൻഡ് യു എ മെയിൽ. നിങ്ങൾ ക്ലാസ് കഴിഞ്ഞ ഉടനെ അത് പെട്ടെന്ന് ഫിൽ ചെയ്യണം കേട്ടോ.
സർ, ആ ഫോമില് ഫസ്റ്റ് തന്നെ കാൽക്കുലസ് നടക്കുന്നത് അതെന്താണ്?
ഏത് ഫോമില്?
സർ ഇപ്പം മെയിൽ ഫോമില്
ഇന്നത്തെ മെയിലുള്ള ചെക്ക് ചെയ്യാൻ പറഞ്ഞു.
Yes.
ഓക്കെ, സി അത് നിങ്ങൾക്ക് ഞാൻ ഫോം എന്താ വെച്ചാൽ നിങ്ങളുടെ ഓരോ വി ഹാവ് ദിസ് ക്ലാസ് കമ്മിറ്റീസ്. ഓക്കെ, ക്ലാസ് കമ്മിറ്റീസ് ഉണ്ട്. ഓരോ സെമിസ്റ്റർ 2 ക്ലാസ് കമ്മിറ്റി ഉണ്ട്. സോ ക്ലാസ് കമ്മിറ്റിയിൽ വി നോമിനേറ്റ് 4 സ്റ്റുഡൻസ്. റാൻഡംലി നമ്മൾ 4 സ്റ്റുഡൻസ് ടീച്ചേഴ്സ് ഒക്കെ ഉണ്ടാവും. എന്നിട്ട് എന്തെങ്കിലും ലാസ്റ്റ് നമുക്ക് എന്തെങ്കിലും ഇമ്പ്രൂവ്മെന്റ് ചെയ്യാനുണ്ടോ ക്ലാസ്സിൽ, നിങ്ങൾക്ക് എന്തെങ്കിലും ചിലപ്പോൾ പിള്ളേർ തോന്നും സാർ ഭയങ്കര സ്പീഡിലാണ് പോകുന്നത്, എനിക്ക് മനസ്സിലാവില്ല, കുറച്ചൊരു സ്പീഡ് കുറയ്ക്കാം, അല്ലെങ്കിൽ സം കൈൻഡ് ഓഫ് സജഷൻസ് സ്റ്റുഡൻസ് ആർക്ക്, അതൊക്കെ ചെയ്യാൻ വേണ്ടിയുള്ള ഒരു ഇതാണ് ക്ലാസ് കമ്മിറ്റി. അപ്പൊ ആ ക്ലാസ് കമ്മിറ്റിയാണ് ഇന്ന് കൂടാൻ പോകുന്നത്. സോ അതില് ബിഫോർ ക്ലാസ് കമ്മിറ്റി ഐ വാണ്ട് ടു നോ നിങ്ങൾക്ക് ഏതൊരു സബ്ജക്റ്റിൽ എന്തെങ്കിലും ഇങ്ങനെ കൺസേൺ ഉണ്ടോ. സോ ഇറ്റ് ഈസ് എന്താ പറയാ, അനോണിമസ് ഫോം ആണ്. നിങ്ങൾ ആരാണെന്നോ എനിക്ക് അറിയത്തില്ല ചെയ്യുന്നത്, കാരണം യു ക്യാൻ സീ യുവർ നെയിം വിൽ നോട്ട് ബി ദർ. അതിൽ ഫസ്റ്റ് ഈസ് കാൽക്കുലസ്, മീൻസ് യു ഹാവ് ടു സജസ്റ്റ് ഇൻ കാൽക്കുലസ് ക്ലാസ്സിൽ എന്തെങ്കിലും ഉണ്ടോ, മെക്കാനിക്സ് ക്ലാസ്സിൽ എന്തെങ്കിലും ഉണ്ടോ എന്നൊക്കെ. അതല്ലേ ചോദിച്ചത് ആ ക്ലാസ്, അതിന്റെ ഇടയിൽ ചോദിച്ചേ അല്ലേ? അല്ലേ ചോദിച്ചതല്ലേ? ചോദിച്ച ആളോട് പോയി ആരാ ചോദിച്ചത്? കേട്ടോ കേട്ടോ, ആരും കേട്ടില്ലേ? കേട്ടില്ല. യു ഹാവ് ടു ഓരോ ക്ലാസ്സിനെയും പറ്റിയുള്ള ഫീഡ്ബാക്ക് ആണ്. നിങ്ങൾക്ക് ചിലപ്പോൾ ക്ലാസ് സ്പീഡിലാന്ന് തോന്നുന്നത്, അല്ലെങ്കിൽ പയ്യെ പോകുന്നത്, അല്ലെങ്കിൽ ക്ലാസ് കുറച്ചുകൂടെ അല്ലെങ്കിൽ കുറച്ച് ഇംഗ്ലീഷ് കൂടുതൽ, അല്ലെങ്കിൽ മലയാളം കൂടുതൽ, എന്തെങ്കിലും ഫീഡ്ബാക്സ്. ഓക്കെ, ജനറലി വി ആർ സപ്പോസ് ടു ടേക്ക് ക്ലാസ്സസ് ഇൻ ഇംഗ്ലീഷ്. That's why I am explaining in English, then I am explaining again in Malayalam. So that's that kind of if you think the Malayalam is too much, that also you can comment. But അങ്ങനെ ക്ലാസ് ഇംപ്രൂവ് ചെയ്യാൻ വേണ്ടി if you have any suggestions you can put in that form. ഓരോ സബ്ജക്റ്റ് കേട്ടോ. അറിയാൻ മനസ്സിലായോ?
Okay, sir.
Yeah, okay. To everyone. So ഈ പ്രോബ്ലം കണ്ടിന്യൂ ചെയ്തോളൂ. പ്രോബ്ലത്തിൽ കിട്ടി, ആരെങ്കിലും ചെയ്തോ? 2 ബോളിന്റെ ഫ്രീ ബോൾ ഡയഗ്രാം വരയ്ക്കണം. So this is a lengthy problem. Lengthy problem in the sense it will take some time to solve. കിട്ടിയോ? ആർക്കെങ്കിലും കിട്ടിയോ? ആർക്കെങ്കിലും കിട്ടിയോ? Okay, so let's see. ആരെങ്കിലും ചെയ്തോ? Anybody? നമ്മൾ ഫസ്റ്റ് ക്ലാസ്സിൽ വെച്ചതാണ്. Anyone has done? Arjun VS. Arjun VS. ചെയ്തോ? ചെയ്തോ അർജുൻ?
FBD വരച്ചു.
FBD diagram വരച്ചോ? Okay, let's draw that. Arjun, just help me. Okay. So let's take this. Tell me, ഇതിൽ എന്തൊക്കെയാണ് ഫോഴ്സ് ചെയ്യാൻ വരയ്ക്കേണ്ടത്?
Gravitation force.
Downward, അല്ലേ?
Downward.
Okay, just let me draw that. Okay.
Contact forces. Two
This is
contact.
500.
500.
Okay. ഏതൊക്കെയാണ് കോണ്ടാക്ട് ഫോഴ്സ്?
സൈഡിലുള്ളതും
ഇതാണോ? ഇതും
അതും അപ്പുറത്തെ ലെഫ്റ്റ് സൈഡിലുള്ളതും.
So this is one contact. Let's say this is another contact. So it will be radial, towards radius. So I'll call this as N1. So this is N1. ഇവിടെ N1 ആണ്. N2. Anything else? Anything else? ഇനി അതിലുണ്ടോ?
നെക്സ്റ്റ് റോളർ
ഇതിലെല്ലാം തീർന്നോ? ഇതിലെല്ലാം തീർന്നോ? ഇവിടെ ഒരു കോണ്ടാക്ട് ഇല്ലേ?
കോണ്ടാക്ട് അത് പറയാൻ വന്നു സാർ. ബി എയും തമ്മിലുള്ള കോണ്ടാക്ട്.
So it will be like this, അല്ലേ? So let's say I will call this as F dash or F1. I'll call this as F1. Okay. അപ്പോൾ ഇതിനെ I will simplify this. ഞാൻ ഒന്നുകൂടെ ഐഡിയലൈസ് ചെയ്ത് വരയ്ക്കാൻ പോവാണ്. So this is there. Okay, that I'll do in the next slide. Okay, what about B? B എന്തൊക്കെയാണ് ഫോഴ്സ് ഉള്ളത്?
Downward force.
So the weight is there, അല്ലേ?
Weight is yes sir. Weight
is there, 500. Then
and the contact force. Contact
force. Let's call this force. This is 3. So
yes,
we have force here, അല്ലേ?
Yes sir.
3. Okay.
ബിയും എയും തമ്മിലുള്ള കോണ്ടാക്ട്.
So the opposite direction. Within the opposite direction, അല്ലേ?
Opposite. Okay.
So but it will be same force, correct? Equal and opposite
yes,
force. Okay. So ഇതാണ് നമ്മുടെ forces. Now let's say can I get these angles also? Okay, fine. Let's see. Now we know this 30 degree. Any angle. Can I find any angles in the angle കണ്ടുപിടിക്കാൻ പറ്റുമോ? So this is basically this will be if I draw the plane here. ഞാൻ ഇവിടെ ചെറുതായിട്ട് plane വരയ്ക്കുകയാണെങ്കിൽ if I draw this plane here and if I draw this, okay, this is plane here, this plane here. Let's say this contact is here. Okay, we know that everybody the 90 degree. There is 90 degree. There is 90 degree. Okay, here also this 90 degree. So, the 90 degree. Okay, now can we find angles? Now the force and the angles are going on. So is it possible like that? Let's say, I think it will be easy if I work out with this. Okay. Now can I find angles? Angles are really empty. Any ideas? What all angles can we find? So ultimately, now these two forces I will take, and the forces I'll take to the next slide. So we'll come back and so in idealize here, let's idealize this. So this is a point. I have a W500 here. Acting vertical down. Okay, then I have a force here which is acting like this. So this is N3 or N3. This is N3. This is 500. I have a force like this. Level force transmissibility which I can put it there. Okay. Now this is F1. 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 So this we know. And now if you find these three angles, we can find these two. Now similarly, I will draw for this also. So the most difficult part in this question is to find the angles. Free body diagram easy basic it will be difficult. Okay. Then remember that. So this force is in this direction. This is what? Okay, this is in this direction. So let's say. Okay, then this force is in this direction. Then this force is in this direction. So this is a little bit more complicated. So this is N2. This is F1. This is, what is this? N1. And this is 500. Okay. So now we are observing that this is easier to solve. Either solve and so this is my A. This is my B. Because force. Now once you find this force, you can put the force here. F1 force then you can find the other values. Okay. Just give me a moment. Try to find that angles. Try to find that angles. Video. So I'll name these angles also. So let's say I want to find angles. Okay. Alpha 1, alpha 2, alpha 3. So first we'll concentrate on this. Okay. We are trying to find angles. Okay, here. Angles. Now, what all angles can we find? Any ideas? Any ideas here? The moon angles are given. So if I force, so it is easier if you just draw the forces here. This is one, and this is one force here, and one force is here. Okay, how do you find the angles? E angle, E angle, E angle. So the force on weight and the normal force. So any ideas how do I find these angles? So this is the most complicated part in the question. Anyone? Hmm. So it will help me if I draw a horizontal line like this, the vertical line like this. Now what all I know? You can see this line and this line. Okay. So this line and this line is making angle 30. So this line and this line, what is the angle here? Can I write here 30? 30. Right?
പറ്റും സാർ പറ്റും
Correct ആണോ? ഇതും പാരലൽ ആണ്. ഇതും പാരലൽ ആണ്. So this is same. ഇതും പാരലൽ. So this is 30, right? Right. So this is 30. Now what is this angle? Horizontal and vertical. The angle in the 90. So what I got? The angle. What is this? 30 plus 90 equal to 120. Okay, correct. Now, so this angle is solved. Now what can I get this angle? Even ഈ angle എന്താണ്? ഈ രണ്ട് തമ്മിലുള്ള angle എന്താണ്? So this is the angle between this line and this line. What is that? ഇതിന്റെ രണ്ടിന്റെ radius same ആണ്. So this height is same as this height. Okay, so this and this is a, what is this? This is a rectangle. So what will be this angle? The angle tell you. Will it be 90 degree? 90 degree. അല്ലേ? 90 degree അല്ലേ? ഇത് രണ്ടുള്ള angle. Because you can see this line and this line. Okay. Then this is one side. This is radius. This is radius. Okay. This is ഈ length correct ആണ്. അപ്പം ഇവിടുന്ന് ഇതിന് parallel ആയിട്ട് ഒരു ലൈൻ വരയ്ക്കാം. So that means അത് extend ചെയ്തു, ഇത് extend ചെയ്തു. So this will be 90 degree. So now it is easy. This is 90 degree. This is 120 degree. What will be this? That's right.
360 minus 120.
360 minus 9. Okay. So how much is this?
360 minus 220. അല്ലേ?
Ah.
എത്ര?
210, right? 210 അല്ലേ?
210.
So 150 degree. Okay. So now can you tell me F1 and N1? Please find value of F1 and N1. F1 and N1 value. F1 and N1 value. So use Lami's theorem. So this is three forces. This is an equilibrium. Okay, and concurrent. So you can use Lami's theorem. Using Lami's theorem, we can say this force divided by this sine of this angle. Okay. So 500 divided by sine of 90 should be equal to F1 divided by sine of 150 should be equal to N3 divided by sine of 120. So what is the value of F1 at? What is the value of F1 at N3? So F1 equal to what? N3 equal to what? So sine 90 is 1. So 500 sine 150 will be the answer of F1. Again, if you consider these two, N3 also will get. ചെയ്യാലോ അല്ലേ? 500 divided by 1. Sine 90 is 1.
250 sir.
So F1 is equal to 250. F2 well N3.
Correct.
433.
433 now. Okay, 433. Good. 433. Good. Okay. Always remember to write units. Okay, so note the force you have to automatically write. Now it is easier for me. So let's say this free body diagram I can now now I know F1. F1 the value I know. F1 the value I know. Okay. This F1's value I know. So F1 is what? F1 is equal to 250. Okay. Now this also, how do we solve? Either this you cannot use damage theorem. Why? Because you have more than 3 forces. Okay. But this you have to use components. രണ്ട് ഡയറക്ഷൻ സ്പ്ലിറ്റ് ചെയ്യുക, എന്നിട്ട് എല്ലാ ഫോഴ്സിന്റെ എക്സ് ഡയറക്ഷനുള്ള കോമ്പണന്റ് കണ്ടുപിടിക്കുക, എല്ലാ ഫോഴ്സിന്റെ വൈ ഡയറക്ഷനുള്ള കോമ്പണന്റ് കണ്ടുപിടിക്കുക. സോ അതിന് കണ്ടുപിടിക്കാൻ വേണ്ടി നമുക്ക് ഇനി വേണ്ടത് എന്താണ്? വി നീഡ് ദിസ് തീറ്റ ആൻഡ് വി നീഡ് ദിസ് തീറ്റ. ഈ രണ്ട് ആംഗിളുകൾ കിട്ടിക്കഴിഞ്ഞാൽ വി ക്യാൻ ഫൈൻഡ് അല്ലേ. സോ 250 ഇസ് ദർ വി ഡു. ഇത് നമുക്കറിയാത്തത് എന്തൊക്കെയാണ്? ദിസ് n1 വി ഡോണ്ട് നോ, n2 വി ഡോണ്ട് നോ, ദീസ് 2 ഫോഴ്സസ് വി ഡോണ്ട് നോ. വി നോ ദീസ് 2 ഫോഴ്സസ്. യു ഹാവ് ടു ഫൈൻഡ് ബൈ കോമ്പണന്റ്സ്. Right. Now what is these 2 angles? So I'll go back here. So let's say I'll call this as beta. This also come. Okay. Now what are the angles? Another angle. We are doing this. So if I draw this, this is one force. This is another force. This is another force. And 1, 2, 3. And this is we have a weight also. So this is a weight, this is the force due to this. This is n1, this is n2. അപ്പോൾ ഇങ്ങനെയാണ്. അപ്പോൾ നമുക്ക് വേണ്ട ഫോഴ്സ് എന്തൊക്കെയാണ്? ഇതും പിന്നെ ഈ ആംഗിളാണ് വേണ്ടത്. Any idea how to find these angles? Okay. Again, this is also quite straightforward. This is 30. നമുക്ക് അറിയാവുന്ന ആംഗിൾ ഒക്കെ നമുക്ക് എഴുതാം. ഇവിടെ 30 ആണ്. Okay. Now if you see this line and this line, okay, it is like ഒരു ലൈൻ ഇങ്ങനെ, ഒരു ലൈൻ ഇങ്ങനെയാണ്. So I'll take those lines on. Okay, if you see, this is one line. This is one line. So this is 30 degree. This is 30. So this is 30 degree. 30 degree. It's very small. Okay. Now finding the angles. Now how do you find the angles? Tell me. So again, this line is there, this line is there, this side, this is 30 degree. Okay. Now this plus this is 90 degree, so this will become 60 degree. Think. Okay. E angle, opposite angles. So this will be same angle. And this plus this will be 90 degree. So this is 60 degree. And this is 30 degree. Okay. Now the angle.
60 opposite 60 അല്ലേ?
ഏതാണ്?
60 opposite 60 ആണല്ലോ അപ്പോൾ.
60യുടെ opposite എന്ന് പറയുമ്പോൾ ഇത് 60 ആണ്. Okay. Now this is 90 degree. So what is this angle? ഇത് 90 degree ആണ്. So what is this angle? 30 degree. മനസ്സിലായില്ലേ? അപ്പോൾ ഇത് 60. So this and this is 60. So നമുക്ക് കിട്ടി. What is this? This is 60. So this is 30. അല്ലേ? So one is this vertical weight. So that is this. Then we have this force here. This ഇതിന്റെ angle നമുക്ക് 60 കിട്ടി. So this will be 30. 30 നമ്മൾ നേരത്തെ കണ്ടുപിടിച്ചതാണ്. So this is equal to 30 degree. Now what about this angle? So that is because between n1 and this vertical. Now this is n1, this is a vertical. This is also 30. 30. Okay. Now this is simpler. Now let's take this to a new slide. Okay. So now forces we know this is 30 degree, this is 30 degree. Okay, you have a 500 here, you have a 250 here. So 250 is from what? F1. 250 is from F1. So this is nothing but F1. This is F1. Okay. Now, since it is in equilibrium, since the roller is in equilibrium, summation of forces in X should be equal to 0. Summation of forces in Y should be equal to 0. Okay. Now let's see summation of forces in X direction of force. Then we'll do a summation of Y. Now, X direction, if I do, I'll take right as positive, Y direction I take up as positive. Okay. Now, what are the forces in X direction? Let's see. I have this N2 here. So N2 under in X direction. So that is in the rightwards, so it's positive. Then I have the component of this force in X direction. So what is that value? So that will be, so this is N1 cos beta, N1 sin beta. So it is in this direction, E direction. So that I can write minus N1 sin 30. So this is about this component. Idinu component. This is cos 30. This is cos 30. This is cos 30. This is sin 30. Okay. So 250. So this is what we need. There is a component in this direction. There is a component in this direction. So this direction component is what we need. So that is 250 cos gamma. So that is also minus cos 30 equal to 0. Okay. Now if I write this vertical directional force, vertical directional N2 doesn't have any component. This have a component N1. So that is N1 cos beta. N1 cos 30. Beta is 30. That is upward, so it's positive. Now, this doesn't have any component. This have a component. So other 250, this is 250 cos, this is 250 sin. So this is in a downward direction. So that is minus 250 sin 30. Okay, 250 sin 30. Then we have 500. Minus 500 equal to 0. So this if you solve, N1 cos 30. So what is the value of cos 30? Cos 30 sin 30 value in substitute half and root 3 by 2. Okay, this is root 3 by 2. Minus 250 into half. Half. Minus 500 equal to 0. Okay, so that means N1 root 3 by 2 equal to 500 plus 125. That is 625. So this means N1 equal to 625 times 2 divided by root 3. So 721.68. 721.68. Okay, 721.68. So that is about N1. In this value, we can substitute it here. So this is the thing that we found. So I'll change the order. Maybe confusing to you. So what I'll do is I'll take this, put it here, take this. Okay, we can substitute the value of N1 here. So this means N2 minus 721.68 times. So 721.68 minus sin 30 is half. Sin 30 is half minus 250 times cos 30. So cos 30 is root 3 by 2 equal to 0. Okay, so this gives me N2 minus, so what is the value? 721.68 by 2. $577. 577.34 equal to 0. So that means N2 equal to 577.34 Newton. Okay. Right. Now, this angles you have to think carefully. Maybe maybe better for practice. But this is very important. Okay, and the questions is very important. You have to learn to solve this. So I'll give you some assignments to solve. Within the video also I'll post. Just once more you watch this. I am posting these videos regularly. Class miss okay. Videos okay. So I think I'll end for the day. But the exam portion cover. So I'll take some extra classes, maybe Saturday or something. Well in advance, I'll inform you. I hope you will be comfortable for coming for 1 hour in Saturday. Okay, assume okay. Now online 1 hour we'll try to find. Right. So this is clear. Yeah. The class committee meeting so that class committee meeting is cancelled. Okay, we'll have it in we will have a course committee. Or a subject separate meeting. Our meeting you can come and tell your issues. Right. So I'll stop now. Just give me a moment.